Red Rock State Park and Amphitheater in Morrison, Colorado is a geological phenomenon that has become a much-loved Colorado location for entertainment, cultural events, and outdoor activities since its opening in 1941. Gigantic sandstone formations surround the stage, giving event-goers a perfect place to hear the work of some of the world's best-known artists. The park boasts itself as the only naturally occurring, acoustically perfect amphitheater in the world. Sitting at 6,450 feet above sea level, Red Rocks features panoramic views of the Denver skyline. To learn about how Red Rocks came to be, we must discuss the physical history of the Earth in this part of the world. Approximately 1 billion years ago, a combination of magma and melted rock was formed into metamorphic rock, which would become Pikes Peak granite. About 500 million years ago, the region began to sink below the surface of a tropical sea, and as it sank, layers upon layers of limestone and mud sediments were deposited on top. 200 million years later, the sinking in the region reversed, and the granite and surrounding sediment were pushed high above the sea's surface. Erosion then stripped away the sedimentary layers, creating the ancestral Rockies. An estimated 280 million years ago, during the time of Pangaea, the continent was dry. Great sand dunes were created, partially burying the ancestral Rockies. Unanchored sand particles pushed by wind were deposited on the slip face. These deposits compressed into fossilized dunes, becoming the Lyons Sandstone. Sandstone layers in the strata can be seen in the upturned formations of Red Rocks. Fluvial erosion over millions of years created a large apron of debris that washed down the ancestral Rockies, breaking them down and leaving the region flat. Sheer pressure and massive force caused the debris to interlock and cement together, creating a 12,000-foot thick pile of sedimentary rock. This sedimentary rock is a conglomerate of coarse red sandstone, red mud, and cream-colored layers of wavy limestone. Streamflow deposits collected in the bottoms of riverbeds led to cross-bedding. These deposits can be seen as diagonal layers of sand and silt in the monoliths at Red Rocks. Groundwater seeping through the rock deposited the red mineral hematite, which is where the deep red color originates. Pennsylvania and Permian rocks, part of the Fountain Formation, can be seen at Red Rocks, as well as at Garden of the Gods, Boulder Flatirons, and Roxborough State Parks. 100 million years ago, the area was again under a shallow sea where layers of sandstone built up to shape the Dakota Formation. This formation has been fossilized and has given us evidence that the area was once a beach where many dinosaurs traveled. Footprints have been left and preserved in the sand all over the Dakota Hogback, a formation that runs parallel to Red Rocks and can be identified by the light cream, gray, and gold coloring. 70 million years ago, the region once again began to sink, and a 600-foot sea from the south moved into and flooded the area. The sea was home to a mile-thick layer of marine mud that deposited on the seafloor. These deposits eventually compressed and became Pierre Shale that is seen near Dinosaur Ridge in Morrison. Marine reptiles such as Mosasaurus and Plesiosaur, a 40-foot sea serpent, became prevalent, as did cannibalistic sharks and fish. The area was also home to the reptile pterosaur, the largest known animal to fly. Over several million years, the waters receded and the continent began to experience cracking, folding, and breaking. Continental plate collision caused mountain uplift and forced the sedimentary rocks to break through. Erosion went to work on the sedimentary rock to create the huge monoliths we see today. The sandstone layers within the monoliths jut out further than the siltstone layers, as they are harder and erode much slower. A 2-million-year ice age smoothed many of the rough edges and softer sediment of the rocks. It is thought that the monoliths stand so tall because they are better cemented than other formations. Weathering and mass wasting continues throughout Red Rocks to this day. Open vertical joints allow mechanical weathering by frost wedging, which causes large blocks of rock to break away. Erosion by exfoliation is occurring at Lizard Head Rock in the north end of the park as large sheets of rock slide away. Biological weathering is seen as large deposits of lichen and moss have formed on the rocks, leaching out minerals and eventually weakening the rock. Cracks in the rocks have allowed small plants and trees to take root, causing further cracking within the rock formation. Red Rocks Park and Amphitheater is a physical history book displaying millions of years of Earth's geological processes. This unique site has evolved into one of the most spectacular locations in the world.